Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our D programming language series. In this lesson, we're going to be talking about reading files. So this means that we're going to be understanding a little bit more about that import stud.stdio, which stands for the standard input output library. And after all, files on your system are one way that we read and write data. This lesson, we're going to be talking about reading, and then make sure you subscribe so you don't miss that lesson about writing to files as well. With that said, though, let's go ahead and dive into the D language standard library and just understand a little bit more. So this time, I'm going to go ahead and take you from the documentation into the library reference. So I've looked at this a little bit, and we'll talk about this more about what the Phobos runtime library is and offers us. But again, D has a rich library. And today I'm going to go ahead and just take us to the standard input-output library here. Let's make this a little bit bigger here. And again, this is the idea of writing in and out data. So let's go ahead and take a look here. Now, what you'll notice immediately in the standard library here is that at the very top, we have something known as a file handle. And this is going to get a little bit into the weeds of things, but let's go ahead and draw just a little bit here. But you'll notice that one of these things is labeled as a file here. Let me just go ahead and highlight that here for a moment. And I'm going to represent a file here that's on your system. Now, the reality is, and if you're coming from a Linux background, this might be familiar if you've done some C or C++ programming, but everything is a file. That's a dirty little secret in the programming world, how everything is represented. Now, a file, as we think of, like my file.txt, for instance, might have some text data in it that you can read. But processes themselves might be files, and that's what popen has to do with. And then if we want to connect to some network or something, well, that's going to open up a sort of file stream where we can store some data from the network and read and write into it. Again, it's all just about input and output, and we need somewhere to store it. But for the purpose of this video, we can just think of an abstraction of a file as something like something holding text data, like we're used to in a text-based document, a source code file, or whatever. So that's what we're going to focus on. Now, some other interesting things here, and let's go ahead and make this a little smaller, is the different ways in which we can read from a file. And the sort of mindset that I want you to have is that we're going to open this file. So let me just go ahead and label this as open, whatever myfile.txt is on our operating system. And then we will be able to read the contents here, maybe by one line at a time here, maybe in chunks, so just looking at things sort of one byte or a few bytes at a time, or maybe reading formatted information here if this is a, say, comma separated file, or again, maybe just reading one line at a time here. So that's the different things that we're going to focus on in this particular lesson. And with that said, let's go ahead and look at file here. So I'm going to go ahead and click on file here. And again, you're going to find that the file is a struct here. Now, we haven't really talked too much about structs and object-oriented programming and ways to aggregate data, but basically this is a collection of attributes here. It's its own object type. So again, folks coming from a C background, a lot of these functions are going to look relatively familiar. But what we want to know is that this file has a few interesting fields or attributes, things like its name, things like its size, for instance, where we're looking in the file currently, and so on. So those will be some of the properties that we're actually going to use with this file structure here. And now I think we're ready to start working with some files here, but there is something we do have to talk about when we open this file here, and that is the paths on our system. So that's where I'll go ahead and start us off. Let's go ahead and move our documentation to the side just for a moment here and try to open up some file. Now, immediately in this directory, you'll notice that I have created myfile.txt. So if you want to follow along, you can go ahead and see this file here. And it's just some lines of data in a file. So something relatively trivial. You can do something like this to play around with. Just go ahead and create a file like this on your system. So in order for us to get started, let's go ahead and make sure that we've imported the standard input-output library here. And let's go ahead and start working with files here. So I'm just going to call auto for our file type. Again, this is going to be something like file here. We'll look at that in a moment here. So auto file equals file, and then I need to open up myfile.txt. And then let's go ahead and just, for the sake of this, go ahead and write the type of file. And then let's go ahead and put type ID of file. Again, anytime we're introducing a new concept and using auto, probably a good idea to see what we're exactly working with here. So let's go ahead and run this here. And we can see that is again this type for file here, as indicated by the structure in the documentation. Okay, so it looks like this actually worked here. Now, why did this work? Well, I'm in the current directory where I'm executing my program. My file.txt is located in this directory. I'm going to go ahead and do something. We've been using rdmd a lot here, but let's just go ahead and use the dmd compiler here and make our program. And if I execute this program, again, it will work. It finds this particular location here. Okay, so no problem there. Let's go ahead and just combine these steps here. So I have the compilation here, and then it'll immediately run our program. Now, what if I make another folder here in this directory? I'm going to call it data, something that we might do here. And then I'm going to move this myfile.txt into the data folder here. So let me go ahead and show you my structure here, or if you prefer, to see that data has again moved here. And again, some of you might not be as familiar with the terminal, but let me just highlight the structure here. So myfile.txt is in this folder. So now let's go ahead and see if I run this program here, what happens. Okay, so let's go ahead and recompile here and then run our program. Well, we're going to get a bunch of errors here. And basically, if we read through these errors here, we're going to get some sort of exception here that says cannot open file myfile.txt in mode RB, no such file or directory. It doesn't exist, right? We have to pass in the location here. So we can use what's known as a relative location here. And what I can do is then just put in /data/myfile.txt, correcting the path. So I know from this executable that if I look in from this location here into data, I can find my actual file here. So that's what's known as a relative path. Now, my other option is to provide the full path here. And I could go ahead and type in home/Mike/YouTube/Dlang/44, and then data/myfile. Let's go ahead and recompile and run this again. And oops, maybe I missed one slash here. Let's do /home. There we are. And now this will work. Now, the problem is your directory structure is probably not the same as mine here, right? If I give you this full line here. So that's why we prefer relative paths here, okay? So relative to where the executable is running, we will pass in this file here, okay? So that's just something that we can do here. So that's relative paths versus absolute paths. Let's go ahead and highlight that here. So relative path, that's what I have up here, versus an absolute path, which would be the full file path, Okay, and the example would be, /home/Mike/ etc., etc. The full path here. We prefer relative file paths in generally. Prefer relative paths. Okay, that way if you make a program and you give it to me, I'll actually be able to run and find the particular file. Now, what are some things that we can do with this file to make sure that we actually find it here? Well, I'm actually going to open up the reference here. Let's open up another Dlang here. And let's go into the documentation, the library reference, and what we're going to be looking for is standard.file, which has some useful utilities for looking around for files, such as if the file actually exists. Okay, so what we typically want to do here is say something like if exists, and I'll have to import standard.file here for exists. And then I would provide this path here, ./data/myfile.txt. Then we'll go ahead and open it up and write out some information about this file here. Okay, so let's go ahead and make sure that this works here after I correct this error. And it looks like this file does indeed exist and we can run it here. So now we can combine this with some things that we've been learning previously in this lesson, like taking in some arguments here. And let's just go ahead and see if our argument here, whatever it is, for our program, I'll go ahead and put args1 here. And that'll be actually be the file that we load just to make this a little bit more dynamic here. Let's go ahead and do that. args1. And now when I run my program, let's just go ahead and compile it in one step here. And when I run it, I'll need to actually pass in a path data/myfile.txt, and we'll see that that's actually running. Okay, so this is just, again, using exists to check if our file exists. Check if our file exists that we are running from the, that we are loading from the command line arguments. And remember, we're using 1 here because that's this argument here. 0 would just be the program here. Okay, so just a little bit of review there, and we've successfully can load our file and make our application more data-driven in this way. So just something cool that we can do in that manner. So now let's get into our file here a little bit here and see some of the properties we have. So again, here is our structure for the file. And again, just to make sure that we've actually opened up our file here, and let's go ahead and write some of these properties of the structure or the attributes. Let me make this fit to our screen here. Let's go ahead and just write out some things like the name here, file.name. Let's go ahead and write out the size. Let's see what other properties there are. Tell, which I mentioned, which is going to tell us where we're currently reading from the file. That one's kind of interesting. So usually at the start here. So let's go ahead and recompile our program and then go ahead and rerun it. And we can see exactly the file that was opened up here. So again, you can see that location. You can see 27 here, which is the size, and then where we are currently in the file. So where am I currently looking? Now, by default, when I open up a file, I'm going to be reading or looking at it from the very first character here, okay, at position 0. Because again, all a file really is a collection of bytes, just like everything else on our computer. So we know that we're starting off at position 0. Until that function is telling me where to go to. There's other useful functions like seek, for instance, which will seek out, say, the 5th byte here. So 0, 1, 2, 3, 4. And I believe that puts us at the, or 5 here for the 5th position here. That'll actually move us through our file here. So you might have seen this, or if you had a hard drive that's sort of seeking for its position, it's moving around and trying to find which actual byte to find. And I'll show you how to do this when we're actually reading from the file. So just a few useful commands. Again, these things will be familiar from a C background. And if you're just new to D, or this is your first programming language, these are just some helpful commands to know about. Okay, so with that said, let's go ahead and actually get into reading the file here. Now, some things that we might actually want to do are to actually read from our file. So let's go ahead and see how we can do that here. And what we'll go ahead and do here is just with our file here. Again, this is how we're referring to this file handle here. I'm just going to do file.readLine here. Now, when I read a line, let's go ahead and look at it in the documentation. It looks like the return can be a specified type here. Okay, so what if I, and the default is a string, which is probably what you want in most cases, but you might be able to read some formatted information if you like. Let's just go ahead and say the string first line equals this. And let's just go ahead and write out first line and see if we read from our file successfully. Now I'm going to go ahead and just simplify our process. I'll use rdmd. And I want to keep our location here the same. And let's just go ahead and run here. Whoops, I got to choose which file I want to run here. Main.d here. And then we could see with our DMD, we can still pass in the command line argument here, which is reading from our file. And we can see that the first line we're reading is some lines here. So is that consistent with our file? Well, I'm going to use NL here. And then let's just go ahead and look at data, my file. And yes, the first line here and NL will give you the numbered output here of your file, is in fact some lines, which is what we read here. Okay, so that is consistent. So what if we want to read some more files here, or rather some more lines from our actual file? Well, we can essentially do this in a loop here. So if I go ahead and look at our actual file here, some of the different things that we can do here, the next thing that I want to show you is end of file here, which is going to become in handy. And that's going to tell us if we seek to the last position. So let's go ahead and, again, try to understand what's going on here. We open this file up here. We're at the 0th position here when we start, and then we read one line of it here. And then when we do our next read, we'll be reading from the second line, and then the third line, and so on and so forth. So let's actually see if that is true. Did we move to a new position here? And let's go ahead and say position here. Go ahead and run this again. And you'll see that our position is now at the 11th byte here. We can actually try to count these out here. If I open up in Vim from data, my text file here, I count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And well, when I hit 10, we didn't move over because the new line is actually a character, and that puts us here at 11 here. Okay, so now we're ready to read of data here. Okay, so let's go ahead and do that. Let's go ahead and just kind of copy this experiment here. And I'm just going to rename this second line here. And then repeat the output. And just update here, second line. And second line. Okay, so let's go ahead and run this again. And now you'll see when we read the second line, we're getting some lines. We're getting that second line of data. And again, we've moved our position here. Okay, so that's the idea. We're moving through the actual data one line at a time, and read line is a handy function to do that. Basically reading until we get to that end line character. Again, the end line character is just the \n. Again, I know it's 2 characters that we type on a keyboard, but that's 1 byte of information here. And it would be whatever is at the end of the file here. So I'll just go ahead and highlight that here, right? We have a new line character. Okay, so that is the idea of moving through a file and reading it. But again, we probably want to do this a little bit more efficiently. So let's go ahead and just comment out some of this experiment here that we've been doing. And once I've got my file opened, what I want to do here is go ahead and let's just go ahead and simplify this and repeat this process. So what I want to do now is say while file, end of file, I'll give you a little sneak preview of this here. And while we're not at the end of the file here, let's just go ahead and from a string, I'm just going to say line equals file dot read line. And then let's just go ahead and write the line out. Okay, so let's see if this effectively reads in our whole file. So if I run this, we in fact get some lines of data in file. All right, so pretty cool here. Now there is one thing you might be wondering about, and I often see this when students are beginning to work with reading data. Since our actual file here, again, if I open up in data myfile.txt, has end lines here, you'll notice that we're getting output of 2 sort of lines here. So really what we want to do if we want a true sort of reading is just to write out the actual line, and it's got an end line character with it. Okay, so now I'll actually read it, and now we'll just get the 3 lines here, again, representing our actual file of data. Now, of course, you might want to add different characters, or you could use different things to maybe put the line number that you might want to do, and of course, that's fine here. Now, of course, if you want to start working with this data in your application, you might also consider making some sort of structure here, a dynamic array, for your data, or maybe your lines, for instance, that you append to. So for instance, we could do lines here and append each of the lines that we're reading. And then let's just go ahead and write out lines. And then I could run this, and then you can see that we've now stored the actual information, and you can see the end character now in our particular file here. Okay, so that's one of the ideas for how to actually read and work with this data here. Now, there are a few other things that I want to show you before we wrap up this lesson, however. So while that is a nice experiment here, let's go ahead and see if we read another line here. What happens? Okay, so go ahead and try to run this. And actually, let's try to do something with it here. Let's say string next line equals read line. And let's just go ahead and write that out as our next line. So again, we've run through our file here, and while we haven't reached the end of the file here, and then we've stored that actual data in our own in-memory data structure here, this dynamic array that we've created. And then we say, well, we want to actually read again some information here. Well, what you'll observe is that our next line is empty, because again, remember when we're reading from these bytes of information, a file is basically just some bytes here. Okay, so we're just reading one line at a time. But when we get to the very end here, our position, we have to rewind or look back here if we want to read again. So there is actually a handy function for this. You can either seek manually to the 0th position, or you can call rewind here, which I'll open up here, which let's go ahead and see what description it gives us. It's basically the same as the C function. So if you open up the manual pages for rewind here, and then search for rewind, let me go ahead and move this here. Here it is in C. I've got to search for it. It sets the file position indicator for the stream to the beginning of the file. So then we can start reading again here, okay? Which is equivalent to just seeking to the 0th position. Okay, so you might see that in various programs here, okay? So let's just go ahead and do that so we can fix our experiment. I can show you how to rewind here. File, rewind, okay? And then when we get our next line, we will again be at the start of the file here. Okay, so I hope you understand that. Again, just think of a file as a stream of bytes that you can kind of read through one at a time. Okay, now there's a few other interesting things I want to show you with files that you can do. For instance, if you want to read not just a line, but maybe a chunk at a time here. So we have this by chunk function we could use, for instance. So let's go ahead and look at by chunk here. There's different ways to use it. In fact, let me see if I can find the file utilities here that we looked at here from file. And let me actually just go here and do reading of our chunks here, a helper function, which is effectively doing the same idea here. We want to just read in some amount of bytes here. I'm going to show you how to do this one byte at a time here. For this experiment, let's go ahead and do a write line chunks. And before I do any experiment, what I'm going to go ahead and do is make sure I rewind our file back to the beginning position here. And basically what I'm going to do here is kind of copy this loop for each. And again, this is just showing you that a file is just bytes that we're reading here, U bytes here. And I'm going to go ahead and say the whatever our chunk size is that we want to read, that's going to determine, you know, how big this actual array is. So some amount of characters, for instance, and then just following chunks. And standard in would be if we're, you know, sort of typing in or reading in information, but the file that we're reading or the input is just file here. Okay, that's where our data is coming from. And for this one, I'm just going to say, you know, one byte at a time here. And then let's just go ahead and do a write line here. And let's just go ahead and write out each of the characters here. And let's go ahead and see what happens when we do this experiment here. Okay, so you can see what we're getting here is it's writing out an array here of each of the characters here. I'm just getting values here. And these are the actual ASCII values. So I do need to cast these to characters so that I actually see the textual representation of them. Okay, let's see here. It's saying, oh, I can't cast of type ubyte array to char. That's because we're looking at just one of these characters, and our array size is just 1 here. So let's just go ahead and do that. And if I scroll through this, you can see that we have some, you know, lines of data in file here. Okay, so I'm just writing those out one at a time here. Now, again, your text processing here. Let's go ahead and get rid of the right line here, just so you can, again, see that we are writing out one chunk at a time here. But if you know you have some data that's streaming in, or maybe for a network, you might want to actually read in chunks of data and process it. Or if you have formatted data in terms of bytes, this could be a convenient way to look through a file. Now, of course, you might be saying that's way too complicated. D makes things easy here. Let me go ahead and show you something else here in our file here. Well, instead of reading by chunks, let's just go ahead and read by lines here. Okay, and this will be the last one I show you, and then we'll wrap up. So let's just go ahead and do a rewind. And instead of doing by chunks, we'll do by lines. This is probably, again, what most folks will want to be doing here. And this time, what we'll actually get here, let's go ahead and get our lines here. So file lines equals file.lines here. And it's probably worth, again, writing out the type here. Let's go ahead and say type ID of file lines. And let's go ahead and start with that here. Okay, and you'll see we have, well, this is actually some sort of structure here, lines. Okay, so let's take a little close look at it. And because it is some sort of structure here, that makes it kind of interesting here. So it's not necessarily giving us the, string array of lines here. Let's go ahead and see if that would be the case here. So could I say string, lines array equals file lines? Let's go ahead and see. Are those types equivalent? No, they're not. Okay. So again, that's just something to consider with this lines thing, but it is an iterable structure where you can sort of read the lines here. Okay. Now I will actually show you byline in a moment here, but let's just go ahead and look at this here. So for each line in our file lines, let's go ahead and see if we could just write out the line here. Okay. And in this case, it says, okay, error cannot infer type for each variable line, perhaps set it explicitly here. Okay, so it can't infer the type here. And that's because it doesn't exactly know how to interpret for this range here. So let's just go ahead and assume it's a string here. So iterates through the lines of a file by using for each. And I think it's going to tell us here that if the line, basically we need to choose string, W string, or D string, which are some of the different types here that we have here. I mean, these are basically our options here for iterating. Okay, so if you need Unicode support or have wide strings, you might use some of these types. Otherwise, string's going to be fine for us for ASCII characters. And again, with our lines experiment here, this is just yet another way to iterate through the file one line at a time here. Okay, relatively simple here. Okay, let's go ahead and do the bylines as well experiment. And let me make sure that I rewind our file, because again, we want to run this experiment from the start of our file every time here. Okay, so now what I'm going to go ahead and do is, again, looking at our structure here. So, we looked at by chunk there. Let's just go ahead and look at by line here. And again, you might have different terminators, but this returns an input range set up to read from the file handle one at a time. Okay, so that's essentially what this is, some sort of range that we're iterating through here. But now I can just do for each line in our file, and I want to look by line here, making sure to capital the L. I'm just going to write out each of the lines. And let's go ahead and make sure I don't duplicate variables, copy and paste error. And again, by lines, some lines of data in file here. In this case, since it is reading by line here, I actually need to write out and separate the lines here. Okay, I'm literally just getting the actual line here, and now I can work with it. Okay, so again, D makes it very easy to just grab the actual file here. You might want to do something again like we did in an earlier experiment where you're actually saving those to some array of the lines here, right? You could just push those into a data structure. So that is something that you could do if you want to work with and manipulate the data. Okay. And again, if it needs to be immutable, you'd use a character array. Okay, so just keep that in mind. So the very last thing that we need to do before I wrap this video up is has to do with more of a operating system thing that, once we've opened this file for manipulating it, meaning to read from it, we have to close the file. So as we close this video, the last thing that we're going to do here is do file.close. Okay, so again, just like in C, we want to make sure that once we're done with the actual file, if you've worked with files in languages like C or Python or anything, we need to make sure that we close the file down. Now, there are some neat things that you can do in the D programming language that we haven't quite talked about, like scope exit, in which I can, so again, just to give you a preview, I can either put this in brackets here. And basically what this will do is ensure, and this is the way that I like to do it, this sort of idiomatic D way, that when I open the file, as soon as I leave the scope of this curly brace here, which I've highlighted on this line, then it will close the file as the very last thing here. Okay, so if you explicitly need to close the file elsewhere, you can do that, but when we exit the current scope, otherwise I'll make sure that I close this file. And sometimes I just like to do that because, again, if these things need to go together, it's just sort of nice, and it's an idiomatic way to do things in D. In languages like C++ or in D, you can also do this, but you might rely on your destructor to make sure that you close something that you have opened in the constructor. This idea of resource acquisition is initialization. I know that's getting a little bit into the weeds of things, so if you haven't seen that, don't worry about it. But the takeaway here is just when you open a file, you need to make sure that you close it when you are done operating on that file. All right, folks. So with that said, that's been a pretty monster lesson on reading files, understanding how files work. Again, just play around with it, create some of your own files, and then we'll get into writing files in a future lesson. If you want to follow along with these lessons and track your progress, of course, check out Courses.io as always. And folks, I hope you enjoyed that lesson. I hope that gets you started with reading in data. It's really one of the cool things in programming once you start doing these types of things. And we will look at some things like reading in formatted data, JSON data, and these sort of things, which are super easy to do in the D programming language. So I'll look forward to seeing you in those lessons. All right, with that said, folks, thanks for your time and attention, and see you in the next one.